Hello, my name is Rob Reynolds. Welcome to Calculus Section 3.10. Today we're going to look at taking the derivative of an inverse function. And to begin, we first of all have to understand the definition of what an inverse is. So if I set y, the function, equal to the inverse function, inverse literally means every time you see an x, write a y, and every time you see a y, write an x. So that's how you can undo an inverse function. Next, we want to try to take the derivative. And so let's take the derivative implicitly. Remember, when you take the derivative of x, it's just a 1. But when you take the derivative of a y, it becomes y prime. So the derivative of sine y is cosine y. And then, of course, we have a y prime. So solving for the derivative, we'll get 1 divided by cosine y. But usually we don't have the derivative set equal to a function in terms of y. We usually have a function set equal to an x. So let's explore a little bit more about what we know. We know cosine squared y plus sine squared y is equal to 1. So my goal is to try to rewrite this cosine y in terms of x. So I'm going to solve for cosine y. And taking the square root of both sides, I'll get 1 minus sine, I'll write it as sine y quantity squared. And right here is a nice definition that I can do some substitution in terms of x and get a nice definition for the cosine of y. The cosine of y is really the square root of 1 minus, well, sine y is x, so I'll write it as x squared. So I'll rewrite this as 1 over the square root of 1 minus x squared for my first look at the derivative. So I don't want you to spend time doing that in the future. I would prefer that you memorize. Sine inverse is 1 over the square root of 1 minus x squared, because we don't have time to always do that every time I ask for the derivative of sine inverse. And of course, next I'm going to ask for the derivative of cosine inverse. We could derive it similarly, but I would go ahead and just start memorizing some trig functions. Of course, Khan Academy also is a great resource to look about how all these are defined. So if you want to know how these definitions come about, you can look in the book or search other videos for that. But here are the definitions that I would expect you to memorize. Now, it looks like there's a lot to memorize, but it's really not that bad because we just did the sine inverse, and check it out. The cosine inverse is exactly the same definition. This is exactly the same as this, except it's just negative, which kind of makes sense because remember when you take the derivative of a c, it always goes negative. So we know that the derivative of cosine was negative sine. So in the same fashion, when you take the derivative of cosine inverse, it's also a negative. And the derivative of tangent inverse, again, I'm not deriving it, is similar. But instead of 1 minus x squared, it's 1 plus x squared, and you drop the radical. And then the cotangent is identical to the tangent inverse. It just has a negative out front. And then for secant, well, the way I kind of remember it, and you can come up with flashcards or whatever works best for you, but the way I kind of remember secant inverse is because I usually get, and students usually get, whether it's 1 minus x squared or down here it's x squared minus 1. So to try to help you think about this, I remember, let's see, sine squared x plus cosine squared x equals 1. That's just the trig identity. It's probably one of the most important trig identities, Pythagorean theorem. But look at what sine squared is really equal to. It's really equal to 1 minus the cosine squared. And so that's how I remember that sine is always that 1 minus that x squared. And then I know it's not mathematical, but this has to do with the inverse. Actually, sine inverse is cosecant inverse. But I remember these have reciprocal property, but instead of reciprocating, I just remember that it kind of flips. Again, it's not mathematical, it's just a memory tool. But if I can remember that the sine inverse kind of goes along with this definition right here. Sine squared is 1 minus that function, so 1 minus the x value. Then I know that secant and cosecant are the flip of that. Instead of 1 minus x squared, we've got x squared minus 1. And then I don't know how you know this, but you've got a little extra. The absolute value of x is hanging out front as well. So learn some method or some tool, some technique, sing a song, come up with a mnemonic, anything to do, so you don't have to sit there and work these things out like I did in the beginning of this video. We just want to memorize these. Another thing that you should have memorized by now is the unit circle. So the way that I taught this was that the sine of pi over 6 is nice, and if the sine of pi over 6 is nice, this is a not nice number. So I started talking about nice numbers and not nice numbers. So if the sine of 6 is nice, then the sine of pi over 3 is not nice. And if the cosine of pi over 6 is not nice, that's going to force this to be nice again. And then I just remember 2 plus 2 is this 4. So I'll stick the square root of 2 over 2 with the 4. Again, nothing mathematical, just a quick, you don't have time to draw triangles. You don't have, my wife teaches at Valley High School. She does long and short sides. Whatever works for you. But I just remember sine of pi over 6 is nice, and then I can kind of figure out from there. 2 plus 2 is 4, and guess what? 3 plus 3 is 6, and any number divided by itself, because tangent is defined as sine over cosine, is a 1. And if you were to take this square root of 3 over 2 and divide by 1/2, you'll just get the square root of 3, but I just remember that just has 3 in it. This has 3 plus 3, which gives you 6. This just has 1 3 in it because it's all my pi over 3. And then, of course, you need to remember that all students take calculus, because if I were to ask for the tangent of something like 2 pi over 3, then I'm in the second quadrant. If you count by pi over 3s, this is 1 pi over 3, 2, 4 pi over 3, and 5 pi over 3. So I remember 2 pi over 3 is in the second quadrant, where only sine and its reciprocal cosecant are positive. So this would be a negative if I had asked for the tangent. So memorize, memorize, memorize. All right, after you have a bunch of stuff memorized, we can work a couple problems. In section 3.7, I talked to you about the chain rule, where we did a little function within a function, a substitution. If we let u be the x squared minus 1, then we'll have a du of 2x floating around. That's the chain rule. So when I'm looking at this, I wouldn't write this, but in your head, you would be thinking, what's the sine inverse of just u? Well, the sine inverse of u would be 1 over the square root, and again, I wouldn't even write this, but this is what's going on in my head. 1 over, and then I remember the 1 minus cosine squared, or 1 minus u squared, and then don't forget about the chain rule, du. So if you had all that kind of going on in your head, which I wouldn't write anything in blue, maybe you could just jump down here to the final answer and say it's 1 over 1 minus this u, which is x squared minus 1 quantity squared, times du. And the du is right here, 2x. So simplifying this maybe a little bit would be 2x divided by, well, let's see what this is. 1 minus, let's see, square the first, twice the product, square the last. Distribute the negative. Of course, we still have this under a radical. So it's the square root of, let's see, I think that's square. So it's square the first, twice the product. The product of x squared and negative 1 is so I think that's going to become a positive 2x squared minus x to the fourth, and the ones will drop away. Final answer. Let's try this one. So this looks like, again, a function within a function, and so we could do u sub like I did before, or the real definition of the chain rule is the derivative of the outside. So let's just start there. The derivative of cosine is negative sine, and the chain rule says take the derivative of the outside, write down the inside, don't do anything to it, and normally we decrease the exponent by 1, but that's not how you take the derivative of cosine. There's no exponent to decrease. But then you take the derivative, here comes the du, the derivative of the inside. So again, chain rule is the derivative of the outside, which is here in yellow, write down the inside times the derivative of the inside. That's chain rule. So I could have done this through u subs as well. You feel comfortable with both methods here. But trying to clean this up a little bit, I got to worry about the derivative of sine inverse. Well, we just learned and memorized, hopefully. Well, at least we're working on memorizing it. After you get done with this assignment, you'll probably have it memorized. And so this final answer, I think I'm done. The only thing I think I can maybe clean up a little bit here is, what's the sign of the sine inverse of x? And well, there's a couple ways you can do this. Way back in section, it might have been 1.3 or 1.4 when I talked about introducing trig to you. Some of you remember how to do this by letting theta equal the sine inverse of x. And inverse really literally means every time you see an x, write a theta, and every time you see a theta, write an x. And so sine is, if I did a quick triangle, this is the opposite, x is opposite, if this is theta, and then this is the hypotenuse, which makes this down here something, which I don't even think I need to find, because then it says find the sine of this theta, because I'm going to replace this with theta. Well, notice that the sine of, that's just opposite. So it's just, all of this drops out, and all you're left with is just, well, the negative hangs in there, is a negative x. And then, of course, you saw the blue square root. So whenever you take the sine of the sine inverse of something, of whatever it is, it just drops away. It's kind of like having x plus 5 and minus 5, because those are inverses of each other. So the sine and the sine inverse undoes whatever is happening to the function, and all you're left with is the function. I hope that makes sense. If not, go back and look at section, I don't know, 1.4 or 1.5, whatever that trig section was. Good, the author had the same solution. This next example says find the derivative and evaluate it at this point. So let's go find the derivative of this thing, which looks like the product rule. So the derivative is, I'm going to do the 1d2 plus 2d1. So 1d2, the derivative of tangent inverse is 1 over 1 plus the x guy squared. And again, I don't have an x. I'm going to do a u sub here, where I'm going to let u be this 1/2 x. Then remember, you're also going to have a du. So there should be a 1/2 floating around. Well, I'll write it now so I don't forget it. But I have a 1/2 floating around. That's my du. And in here is x over 2 for my u and du. Every time you have a u, you also have a du. So remember, I'm in the middle of the product rule because I've got a function times a function. So it's 1d2 plus 2 tangent inverse of x over 2 d1, which is just a 1, which I wouldn't even write, but I'll write it so you can see the entire product rule. So let's see if I can try to clean this up a little bit. This guy's kind of a mess. So 1 over 1 plus x squared over 4. I'll change this to 4/4. So it's 1 over x squared plus 4 divided by 4. And instead of dividing by fraction, we can multiply by the reciprocals. This is really 4 over x squared plus 4. Of course, I've got another x floating around. Well, frankly, I've got a 2 down below as well. I could probably cancel. And I have this. So let's see. I'm getting closer. 2x over x squared plus 4 plus this tangent inverse of x over 2. Remember, they didn't just say find the derivative, they said evaluate it at this point. So I'm going to evaluate it at 2 square roots of 3, which I think if I have the correct derivative, then I should be able to evaluate this. So let's try and take 2 times 2 square roots of 3 divided by 2 square roots of 3 squared plus 4 plus the tangent inverse. Looks like the 2's are just going to cancel, so I just got the square root of 3. And I know the tangent, I wrote squared, it should have been inverse. I know the tangent inverse of the square root of 3 because I had just had that memorized on the previous slide, and that has to do with a pi over 3. Remember, tangent inverse is only defined between negative pi over 2 and pi over 2. And these are your positives and these are your negatives. So this is a positive. If this would have been a negative, I would have said negative pi over 3 because, I can't be careful, you can't say 5 pi over 3, even though 5 pi over 3 is right here, because 5 pi over 3 is outside the domain. You've got to stay between negative pi over 2 and pi over 2. So I think I have a positive because this is positive. And then this guy simplifies to 4 square roots of 3 over 12 plus 4 and 12 plus 4 plus, and I think I'm done. Pi over 3 plus the square root of 3 over 4 for a final solution. And then I think there's a part B. Oh, good. The author got the same thing. Let's see if I can go back. There's my part B. I'll see if I can grab him real quick. And part B says this, and I'll see if I can get a semi-clean page. Got some extra stuff floating around in here. All right, so let's see if I can erase just a little bit. This one is taking the derivative of secant inverse. And the derivative, because it says find the tangent line, and the derivative of secant inverse, if you remember, is 1 over, and I know I've got this square root, instead of 1 minus, I think it's the u squared, oops, u squared minus 1. In this case, u is 2x, and don't forget you'll have a du floating around. I'll write that now so I don't forget. And 2x, and then remember you have this absolute value of x floating out front. But it's really absolute value of u floating out front. And remember that u is really 2x because I did a u sub. So 1 over the absolute value of 2x, the square root of 4x squared minus 1. Well, let's go ahead and just put this 2 up top. So it looks a little bit nicer. And lo and behold, I think the absolute value of 2 is just 2. So I think we can actually cancel those 2's as well. And then start evaluating. So we've got 1 over the absolute value of x, the square root of 4x squared minus 1 evaluated at my x equals 1. And so this is 1 over, well, this is a 1. This is 4 minus 1, or square root of 3. Oh, and then they say write, so I got the slope. And now I'm ready to write the equation of the line. Y equals, you can either write that the square root of 3 over 3, or you can just leave it 1 over the square root of 3. In calculus, we don't mind radicals so much. X plus b. And then you plug in for your x and your y and solve for b. Of course, you can always go to point slope form like the author does, like MyMathLab does, and like every other calculus teacher I've ever seen. My calc teacher just showed me this method, and so that's what I've used. Unfortunately, no matter what method you use, your y-intercept is not pretty. So the final solution is y equals the slope, 1 over the square root of 3x, plus this terrible b value, which I suppose you could change to a decimal, but I prefer exact answers unless they asked you to round. So let's see. There was part A. And yay, the author did the same thing, but of course they did this y minus y is equal to slope, x minus x definition. So that's the bulk of the lesson. There's a couple word problems left for some examples. I don't think you're going to have too much trouble. I've got them worked out for you. I would encourage you to go to Blackboard, download the PDF file, and work through some of these because, again, these are all good. It's just for the length of, for the sake of the time of the video. I won't go through all of them, but all of these are excellent problems that are at the caliber that you should know. The last thing I just want to share with you is this derivative of the inverse function. This will save you a little bit of time if you know this definition. Remember, the derivative is nothing more than the slope of the tangent line. So the slope is of an inverse function is really just the reciprocal of slope. So if they go through and ask you to kind of derive that here on this, if you want to know why that works, and I just need to go through this example real quick to show you that you don't need to find the inverse function to find its slope. All we need to do is find the slope of the function and then reciprocate it, and that will be the slope of the inverse function. Finding the inverse of this function is a little bit difficult because every time you see an x, you got to write a y, and every time you see a y, write an x. So we're going to try to avoid that. Let's just go find the derivative of this function, which I believe will turn out to be 1 over 2 square roots of x plus 2x, and then evaluate that function for this point 3. Well, I'm pausing here because I think I just did that wrong. Because I don't want to plug in the 3, just made the same mistake that students make, because I'm doing the inverse. This is my x, this is my y, and so the inverse function would be y comma x. So that means that my x value is really a 1 on the inverse function. So I really think I want to plug in the 1, which doesn't seem intuitive until you understand the definition of inverse. Every time you see an x, write a y, and every time you see a y, write an x. So if I really am finding the inverse function, instead of plugging in the x, I think I have to plug in the y. I'll write this out for you in a second. But if I do that, I get 1/2 plus 2, which is 5/2. So let's see if we can make sense of this. We're trying to find the slope of the curve of the inverse function at this point. Well, the inverse function's derivative at this point 3, that's the x, the inverse of the derivative is this, according to the definition, it is the same thing as 1 over the derivative of f prime 1. And so that's why I had to switch to this inverse, because this is, that's the definition right back here. So this is your y sub 0, and that becomes your x sub 0. I think this is right. So let's see. 1 over 5/2 turns out to be 2/5. And so the only tricky part is maybe right here, this little thing right here. We have to remember to plug in the y instead of the x because it's an inverse function. And yep, the author says the same thing. And he might explain it just a little bit better than me. So read through that. I hope this video was helpful. If you have any questions, please feel free to email me. Thanks.